This example asks us to evaluate the limits at infinity for various forms of e to the x and natural log x. So let's start by looking at parts a and b. We have the limit as x goes to infinity of e to the x, and the same thing with negative infinity for part b. The key here is to know the graph of e to the x. And that's something you should carry around in your head for easy recall, right? You shouldn't have to think about what e to the x looks like. You want it to be something that's just almost like a picture stamped in your brain that you can easily recall very quickly. Here's what it looks like, right? So along the left, it kind of goes along the x-axis asymptotically, and then it goes to the point 1, 0, and then it goes up exponentially. Now, this isn't an exact graph because the point isn't to get an exact graph right now. The point is to have a general shape of the graph. Because from this, we can easily look at what happens to these limits. We're making very visual arguments here. So from this graph, we can quickly see that as x goes to infinity, f of x also goes to infinity, right? It goes up, in fact, very quickly to infinity. So the limit as x goes to positive infinity of e to the x is indeed infinity. All right, off in the negative direction, as we go to negative infinity, we can see this thing is approaching 0 actually. So the limit as x goes to negative infinity of e to the x is 0. These are very quick results if you're working off the graph itself. Let's take a look at parts C and D. We have the limit as x goes to infinity of e to the negative x now, and then the same thing as x goes to negative infinity for part D. Okay, so once again, we rely on the graph of e to the negative x, and that's another one you should be carrying around in your mind as something you can very quickly jot down. Well, this graph is a reflection about the y-axis of e to the x. So it will come down something like so, go through the point 0, 1, and then approach the x-axis asymptotically. Right, these aren't perfect graphs. The point is to be able to know what the general shape of them is, because then we can quickly talk about the limits. And indeed, we can now see that the limit as x goes to infinity of e to the negative x is 0. The function itself is approaching 0, off in the right direction there. So for part C, we have 0. And for part D, as we go to negative infinity, this function is blasting off to infinity. So for part D, we have indeed infinity. Okay, for parts E and F, we're asking about the natural log. So for part E, we have the limit as x goes to infinity of natural log of x. And for part F, we have the limit as x goes to 0 from the right of natural log x. So pause here and ask yourself, why not the limit as x goes to negative infinity of natural log of x? Okay, well, just as in the previous parts of this exercise, we'll rely on the graph of natural log of x to obtain these limits. So this is yet another graph that you should be carrying around mentally, right? You don't want to have to think about what the graph of natural log looks like. It really tells us a lot about how natural log behaves, so it's worth it to know this graph along with the graph of e to the x, sine x, cos x, tan x, etc. Well, the graph of natural log looks like this. It approaches the y-axis asymptotically like so, and then it comes to this point 1, 0, and then it kind of bends over and goes off like this. Right? That's a rough shape. I'm not trying to get an exact graph because the point is to get these limits out at the various infinities. So from this graph, we can see that natural log is not defined for anything less than 0 in the x direction. So it wouldn't make sense to ask what the limit as x goes to negative infinity for natural log x is. Okay, well now we can get these limits. As x goes to infinity, note that the function natural log of x is slowly rising, but rising nonetheless. So this function does approach infinity as x goes to infinity. So part A is infinity. I'm sorry, part E. And for part F, as x goes to 0 from the right, okay, we can look at our graph and we're clearly going down towards negative infinity. The function is as x goes to 0 from the right. So that gives us negative infinity for part F.